Away we go with some examples from 3.2. I'm going to pull some out of the book here that are should be similar to your homework assignment. May do a couple that are different, but one thing you should do is practice these as much as you can. Try some odd-numbered problems and take as many derivatives as you can. The better you are at taking derivatives, the more success you're going to have in this class. So you need to get as much practice as possible. Let's look at a few out of the first section here. Number 6 is just asked us to differentiate this function y equals e to the x divided by 1 plus x. Well, we have a quotient here, and so it looks like the quotient rule is going to be what we want. So let's use the correct notation. Always use the correct notation. dy dx. What is it equal to? It's equal to the bottom function, 1 plus x, times the derivative of the top. So I'm just going to write that as we're going to take the derivative of e to the x minus the top function times the derivative of the bottom, all divided by the bottom squared. So I'm using this prime notation here to say we're going to take the derivatives. So we got 1 plus x times, let's see, the derivative of e to the x, well, e stands for easy, that's just e to the x, minus the bottom function left alone, times the derivative of the top. Well, the derivative of the constant is 0, and the derivative of x is just the coefficient there, which is 1. So we just have a 1 there. All that divided by 1 plus x quantity squared. Can we simplify this at all? If we distribute this e to the x through the first quantity, we have 1 times e to the x plus x times e to the x minus 1 times e to the x all over that quantity of 1 plus x squared. And so sure enough, we do get a little simplification here as those add to 0, and we're left with x e to the x over the quantity 1 plus x squared. You don't need to multiply that 1 plus x out and FOIL that out. You certainly don't write 1 plus x squared by just squaring both terms. You need to FOIL. If you are going to write it out, you need to FOIL it. 1 plus x times the quantity 1 plus x to get 1 plus 2x plus x squared. But you can just leave it like that. Let's try a couple more here. Number 9 looks like it's kind of a tricky one. Let's see if we can get that started. We have a function called capital F. Its independent variable here is y, so we're going to be taking the derivative with respect to y. It's 1 over y squared minus 3 over y to the 4th. That times the quantity of y plus 5y cubed. Now we have a couple different ways we can go about this. You can see we do have a product of two functions. The first function is this quantity 1 over y squared minus 3 over y to the 4th. The second quantity, the second function that's being multiplied is y plus 5y cubed. So we're thinking product rule here because we have a product of two functions. But before I do that, I'm going to rewrite the function. I'm going to rewrite these first couple of terms in different ways. And it's just going to make my life a little bit easier, because when I take the derivative of 1 over y squared, for example, we talked about in the last video, we could use the quotient rule on that, but usually it's going to be easier to rewrite that with a negative exponent as y to the minus 2 power. Same thing here. I could use the quotient rule on negative 3 over y to the 4th, but it's going to be easier to just rewrite that as negative 3 times y to the negative 4th. So I have that times this quantity of y plus 5 cubed. Now again, I still have a choice here. I don't have to use the product rule per se. I could do a FOIL here and multiply these two binomials out and get some sort of power function with multiple terms that I could use the power rule on. But I'm going to go ahead and use the product rule here. So f prime of y then is going to be what? Make sure you use the correct notation when you start your derivative. Call it the derivative. F prime of y, it's the first. So we're going to leave the first function alone. Times the derivative of the second. Well, the derivative of y is 1, plus the derivative of 5y cubed, bring the 3 down, multiply it by the 5 to get 15y squared. So there's first times derivative of the second, plus to that we want to add the second function left alone, the original second function, y plus 5y cubed, times the derivative of the first. Well, derivative of y to the negative 2, just a power rule here. That's negative 2y to the, let's see, negative 2 minus 1 is a minus 3. And then negative 4 times the negative 3 will be a positive 12y to the negative 4 minus 1 is negative 5 power. So this is our solution here. F prime of y is equal to all of this. And again, don't simplify that. Make it easier on you, make it easier on me if I'm grading it. Just leave your answer just like that. Y to the negative 2 minus 3y to the negative 4 times the, remember this is the first, times derivative of the second, plus the second function left alone, times the derivative of the first. First times derivative of the second, plus second times derivative of the first is your product rule. Try a couple more problems here. How about number 12? Looks like we have a function y equals t cubed plus t divided by t to the 4th minus 2. Alright, I'm going to find the derivative here. We have a quotient, and it doesn't look like we can simplify our way out of that using the quotient rule here. So our correct derivative notation is dy dt. Make sure you use that. And it's going to be the bottom times the derivative of the top. So the derivative of the top is going to be a 3t squared plus the derivative of t is just 1. So there's bottom times the derivative of the top minus the top function left alone, t cubed plus t, times the derivative of the bottom, which is going to be 4t cubed, and that's it, right? Because negative 2 is a constant, the derivative of the constant is 0. So there's bottom times derivative of the top minus the top times the derivative of the bottom, and then we just put that over the bottom squared. So we just write it like that. And we could try and see if we could simplify a little bit here. Let's see. Yeah, we actually are going to be able to. Let's go ahead and simplify the numerator a little bit. If we FOIL these out, we get 3t to the 6th plus t to the 4th minus 6t squared minus 2 minus, FOILing this out, we get 4t to the 6th. I guess we don't FOIL it, we just distribute that, plus 4t to the 4th all over the quantity of t to the 4th minus 2 squared. So we have 3t to the 6th plus t to the 4th minus 6t squared minus 2 minus 4t to the 6th minus 4t to the 4th all over that quantity of t to the 4th minus 2 squared. And so what do we get then? 3t to the 6th minus 4t to the 6th is going to leave us with a negative t to the 6th. So we took care of those. Positive t to the 4th minus 4t to the 4th will be a minus 3t to the 4th. And then looks like minus 6t squared minus 2. All of that divided by, let's see if I can try that again. All of that divided by t to the 4th minus 2, that quantity squared. The denominator squared. So again, bottom times derivative of the top minus top times the derivative of the bottom, all over the bottom squared, or low d high minus high d low, all above the square below. You put that to music and have a nice little song. And you can always remember the quotient rule that way. All right, next problem I want to look at is number 22. 22, we have a function y equals the square root of x divided by x plus 1. And we want to find the equation of the line tangent and the normal line to this curve at the point. And the point that we're looking at is 4, 0.4. Now let's first of all talk about the equation of line tangent. That's something we've talked about before. Remember, for a given function, the equation of the line tangent is going to be the line that touches the graph at that particular point and has a slope that's equal to the derivative. So we need to find the derivative of this function to be able to find the slope of our tangent line. Before we do that, let's go ahead and I'm going to rewrite y real quick. Instead of the square root of x, I'm going to write that as x to the 1/2. X to the 1/2 divided by x plus 1. So now dy dx, move this down a little bit. Dy dx, according to the quotient rule here, is going to be the bottom times the derivative of the top. Derivative of x to the 1/2 is 1/2 x to the negative 1/2, using the power rule there, minus the top, which is x to the 1/2, times the derivative of the bottom. The derivative of x plus 1 is just the coefficient on x, which is 1. Derivative of 1 by itself is 0, so we just have that all over x plus 1, that quantity squared. Low d high minus high d low, all above the square below. Now we were interested in the derivative at our x value of 4. So let's take dy dx at x equals 4, and we'll just plug it in before we simplify here. So we have 4 plus 1 times 1/2, 4 to the negative 1/2, minus 4 to the 1/2 times 1, all over 4 plus 1 quantity squared. Let's see what we get for that. We get 5 times, let's see, 1/2 times 4 to the negative 1/2, that's 1 over the square root of 4, minus 4 to the 1/2 is the square root of 4, all divided by 4 plus 1, which is 5, quantity squared. So we get 5 times, let's see, this is 1/2 times 1/2, minus the square root of 4, which is 2, all over 5 squared, which is 25. So we get, let's see, 5 times a fourth minus 2 over 25. So we get 5 fourths minus 2, which is the same as 8 fourths, over 25. Come down here. And so we get negative 3 fourths over 25, or negative 3 over 100. Negative 3 over 100. If we flip the 25 over 1 up, 1 over 25, 4 times 25 is 100. So our slope is, if you like, negative 0.03. That's the slope of the line tangent. Alright, so we can go ahead and use, let's see, y equals mx plus b form to find the equation of the line. We want a line with a slope of negative 0.03 that goes through the point, remember, was 4, 0.4. So if we plug in 0.4 for y, 4 for x, and negative 0.03 for m, we should be able to find b. So we'll have 0.4 equals m of negative 0.03 times x, which is 4, plus b. Solve this for b, and we have our equation. Let's see, so 0.4 equals, if we take 4 times negative 0.3, we get negative 0.12. And if we add that, we're going to get 0.16. That's not right, is it? No, how about 0.4 plus 1? How about 0.56? How about 0.52? Maybe let's try that. How about an equal sign? That's what b is equal to. So we have the equation of our line. Y is equal to our slope of negative 0.03 times x plus our y-intercept of 0.52. Let's take a look at the graph and see if that bears out. Okay, so I went ahead and put in our original function. Y is equal to the square root of x divided by the quantity of x plus 1. And so at the point 4, comma 0.4, which is this point right here, so pretty close right to that spot. Let's see, we said that the equation of the line tangent was, what did we say, negative 0.03x plus 0.52. And they should be touching the graph right at this point here and in the same direction as it. And yeah, that's what we get. It's tangent to the curve at that particular point. This curve is almost like a line there anyway, so it really matches the curve up very well at that point. Now the normal line is actually a line that is perpendicular to the tangent line. So the normal line is going to be a line that has this shape to it going through our point with a slope that is, well, what's the slope of a perpendicular line? It's a negative reciprocal of the slope of the given line. So if we want to look at the normal line here, then the slope of that is going to be the reciprocal, the negative reciprocal of the original slope of 0.03, actually negative 0.03. So we have a negative over a negative, which is going to be a positive. We have a positive 1 over, now remember 0.03 is the same as 3 over 100, so if we flip that up, we get a positive 100 over 3 as our slope for the normal line. So now we have a line that's going through the point, same point of 4.4 with the slope of 100 over 3. And so we have y equals mx plus b form again. Y of 0.4 equals m, which is 100 over 3, times x, which is, let's see, that's 4 plus b. Let's solve this for b. 4 is the same as 4/10, equals 400 over 3 plus b. And so b is equal to 4/10 minus 400 over 3. We're going to have to get that to a common denominator of, looks like 30. So 3 over 3 here, 10 over 10 here. So we have 12 over 30 minus 4,000 over 30 is equal to b. And so that gives me a negative 3988 over 30 is equal to b. It looks kind of funny, but I think it's right. Let's see, we got y then is equal to our slope of 100 over 3x minus our y-intercept of 3988 over 30. That's a 3 right there. Let's go ahead and put that into our graph and see if we can get a normal line there, the way it's supposed to look. So we see this is going to be a 100 over 3x minus the quantity of 3988 over 30. Now what we should see here is we should see a line that is going right through this point here and perpendicular to our tangent line. Let's hope it works. There it is. Yeah, perpendicular to our tangent line going right to that point at 4, 0.4. So that's how we find the equation of a normal line. It's just perpendicular to the tangent line. So the slopes are negative reciprocals of each other. Okay, we got time for maybe one or two more problems here. I want to get you started on number 28, where we have a function f of x, and it is equal to x divided by x squared plus 1. And we want to find f prime and f double prime. So let's start with f prime. This is a quotient rule. So we'll have the bottom, x squared plus 1, times the derivative of the top, which is just 1, minus the top, which is x, times the derivative of the bottom, which is going to be just 2x, all above the square below, all over x squared plus 1 quantity squared. Now you do want to simplify this because you're finding another derivative. So normally if you're just asked to take a derivative, take your derivative, maybe do some simplification, but in general you don't really have to simplify too much. I'm not going to be too picky about it, but since we're going to be taking another derivative, it's going to be easier on you if you do simplify. So we have x squared plus 1 minus 2x squared all over the quantity of x squared plus 1 squared. So we get x squared minus 2x squared is a negative x squared plus 1 over the quantity of x squared plus 1 quantity squared. Now here's the thing here. In order to do this derivative, again, what you're going to have to do, you have a couple of options, because remember, as you take the derivative of this function, you're going to have to at some point take the derivative of this denominator. To take the derivative of this denominator, you can either use the product rule, because this is two functions multiplied together, x squared plus 1 times x squared plus 1, or you may want to go ahead and FOIL it out first. If I FOIL out x squared plus 1 times x squared plus 1, we get x to the fourth plus 2x squared plus 1. So this is probably the form that I would use then to go ahead and find f double prime of x, which I will leave to you to do. But don't worry about simplifying that then, that f double prime of x. Alright, and the last one I want to look at is number 42. We're given a function f of x. It's equal to x squared times e to the x, and we're asked where is this function concave down. So where is it concave down? Well, remember that a function is concave down if and only if the second derivative is negative. Function's concave down if the second derivative is negative. So we need to find out where that second derivative is negative, which means we need to find the second derivative. In order to get to the second derivative, we first have to get the first derivative. We have a product of two functions here, so let's use the product rule, which says we'll take the first and leave it alone times the derivative of the second. Well, the derivative of e to the x is e to the x. First times derivative of the second plus the second left alone times the derivative of the first, which is 2x. Let's see if we can simplify this a little bit. Can't really. We got x squared e to the x plus 2x e to the x. What I may do here actually is let's go ahead and factor out an e to the x out of both terms. So I have e to the x times the quantity of x squared plus 2x. Alright, now we're going to need that second derivative because, again, I'm looking for where my concavity is downward, which means my second derivative is negative. So now we can find the second derivative, and again we'll have a product rule. We have one function of e to the x and a second function of x squared plus 2x. Alright, so we're going to have then the first times the derivative of the second, which is 2x plus 2, plus the second, x squared plus 2x, times the derivative of the first, derivative of e to the x is just e to the x. See if we can simplify this at all. Distributing the e to the x's through here, we get 2x e to the x plus 2e to the x plus x squared e to the x plus 2x e to the x. A couple common terms here, there and there. So we get, looks like an x squared e to the x plus 4x e to the x plus 2e to the x. So combining those two to get that 4x e to the x. And again, we can think of this as e to the x times x squared plus 4x plus 2 here. So again, this is our second derivative. What are we looking for? Where is the function concave down? That's where the second derivative is negative. So we want to find out where is this function negative. Well, if you think about this function, e to the x times the quantity of x squared plus 4x plus 2. Is that what the second derivative came out to be? Yeah. Where is that less than 0? Well, really only we need to consider is the polynomial part. E to the x is always greater than 0. So the only way this thing can be negative is if this polynomial part, x squared plus 4x plus 2, is less than 0. Now, you need to find out where this is going to be less than 0. Think about what you're looking at here. You're looking at a quadratic function, which is going to be concave, well, a quadratic function, which opens up. So you're going to have to find the two places where your function is equal to 0, and then the interval in between those two places, I mean, let's say this is the point A here and the point B here. Well, the interval then in between those two spots, between a and b, is going to be where the function is less than 0. Your second derivative is less than 0, and thus where your original function is concave down. So again, what you're going to do is you're going to solve this equation. Where does x squared plus 4x plus 2 equal to 0? Solve that equation. That's going to give you these 2 points, a and b here. And then between those 2 points, since you have a parabola opening up, between those 2 points is where your function is negative, and that will be the interval then where the original function is concave down, because that's where your second derivative is negative. You probably need to use the old quadratic formula on this one, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where a is equal to 1, b is equal to 4, c is equal to 2. Alright, good luck on that, and good luck on your 3.2 homework. Your password is Procrustean, which is something that students have accused me of being on occasion. It means having a ruthless disregard of special circumstances or individual differences. Procrustean, Procrustean, is your password for 3.2. Good luck.